Hey, grade 8, really short topic today on extending human vision. So this is all about different technologies that we've developed in order to see things as humans that we wouldn't normally be able to see. So let's get into it. There we go. So first, we're going to talk about telescopes. Telescopes, of course, allow us to see things that are distant or far away, be able to see them more clearly. It magnifies them for us so that we can see details that we wouldn't normally be able to see. So for example, if we use the telescope to take a look at the moon, we're going to be able to see things like craters and stuff that we wouldn't be able to see if we were just looking at it with our naked eyes. So there's different kinds of telescopes. We're going to talk about both, and they actually relate to what we've learned so far in, in this unit. So we've learned both about lenses and about mirrors. So the first one we're going to talk about is a reflecting telescope. And a reflecting telescope enlarges what is being looked at by using a concave mirror. And you know that a concave mirror is one that has the cave in it. So it's got the dip in the middle, and it's smaller in the middle than it is on the edges, or thinner in the middle. And that allows the image to get enlarged. So you can see more detail and see things magnified from what you normally see. So light comes in, it bounces off of the mirror, and then it goes to actually another mirror that's kind of in the middle here, and then goes to the eyepiece. And that's how a reflecting mirror works. Sorry, not reflecting mirror, reflecting telescope. You can tell a telescope is a reflecting telescope because it's normally kind of wider or thicker than a refracting telescope that we're going to look at next that uses lenses. So this is quite a bit wider and shorter or stubbier. Refracting telescopes are normally longer and thinner, and they instead use lenses or large convex lenses to focus the light. So we have here two convex lenses which cause the light rays to converge. And then the eyepiece lens here makes it so that your eye can see it by bringing the rays back. But as a result, it shows a thing that's far away in much more detail and enlarges it for you so that you have a larger image. So that is a refracting telescope. What's interesting about this is it's actually similar to the lens that we have in the front of our eye, that we have this convex lens here that then changes it so that it's enlarged and hits our eye. So that's a refracting telescope. Binoculars are like two refracting, I don't like reflecting, well, I guess it kind of works. It's kind of a mix of reflecting and refracting, but it's two telescopes mounted side by side, and this uses glass blocks inside the binoculars called prisms, and they serve as mirrors that then bounce the ray around to make it so that it's almost like in a larger tube than it actually is. So the light that comes into the binocular bounces around quite a bit back and forth against these prism walls. And when they bounce back and forth, it's as if I straightened out this ray, this back and forth curve, it would be as if it was a much larger tube that it's going through. So light in binoculars is reflected back and forth inside a short tube, and that also serves to enlarge the image. We have here, as you can see, lenses, right? Objective lenses that are going to enlarge the image, allows more light to come in, and then as a result it goes to smaller right here. So again, we're going to actually have these convex lenses here that allow us to see the image larger than it actually is by converging the light. So that's binoculars. Moving forward, microscopes. Microscopes help us see small objects much more clearly. Compound microscopes have more than one lens in order to do this. So they have normally what we call an objective lens, and then an ocular lens, and then a few other lenses in the middle as well. The eyepiece then magnifies the image further. What's interesting is when we look at the different objective lenses on a microscope, the larger the magnification, the longer the tube is. So normally the longer the tube, the more it actually is able to magnify. Using more than one lens in both the eyepiece and the objective helps improve the sharpness and the magnification of the image. So that is a microscope. Finally, I want to talk about what about parts of the electromagnetic spectrum that we can't see. So we can see the visible light portion of the spectrum, but what about other parts like ultraviolet and infrared? So this is a camera, an infrared or a thermal camera that shows us infrared radiation that we normally can't see with the naked eye. So this is kind of neat, and this is used a lot in like home inspections and other stuff for us to be able to see, for example, where drafts are occurring or where there's not a lot of insulation, or even where there's water damage in the wall, because it's going to be much cooler where we have water than when we don't. Night vision is another example. This is normally using light that we can see, but just enhancing it a ton and making it so that we can see it even in low light conditions. Night vision is a really cool technology. Radio telescope takes radio waves from space and then turns it into data and images that we can see. And this is how we find a lot of distant objects in the universe and in our galaxy, by using the radio waves that they transmit and then being able to turn that into data and into an image to be able to study it further. So just a few different ones to kind of look at. The main ones that we care about, though, is just kind of the idea of telescopes. You should know the difference between a reflecting and a refracting telescope. Reflecting uses a concave mirror. Refracting telescope uses a convex lens, is the primary thing that actually causes that to happen, which causes the rays to converge. And then knowing that binoculars involves a bunch of reflecting back and forth and then some lenses in order to make it as if the tube is longer than it actually is, which allows us to have a telescope that is a lot essentially shorter in binoculars than it normally would be with using these prisms and bouncing the light rays around. So once it goes through this convex lens, as it goes in, right, it has a bunch of time as it's going on these prisms, bouncing back and forth to bring the rays together for them to converge in order to reach this, where it turns back into straight rays and then goes to your eye. So this would be a concave lens probably over here, which would then make it so that it can go to your eye and you can see it properly. And then microscopes uses a bunch of different lenses in order to allow you to see things. And primarily, again, we're going to have convex lenses, as you can see here, that enable us to enlarge, just like you would see in a magnifying glass where you have convex lenses. But, you know, microscopes are pretty complex, pretty fancy. And when we focus, we are moving the lenses closer or further away from the specimen, from the object we're looking at, in order to bring it into focus so that it is converging at the right space. All right, so that's it for today's lesson. It's a short one, but there's also a lot of videos for you to watch embedded in this to learn more about these different devices and technologies. Have a good rest of your day.